In this tutorial, we're looking at 2023 Paper 1 Question 9. The first few parts of this question are just about factors. We start off with 2 to the power 4. We're told that it has 5 factors. We're asked to work out all of those factors, and we're asked to write them in the form of 2 to the power something. Well, first of all, 2 to the power 4 is 16. And it's easy enough to identify the 5 factors are 16, 8, 4, 2, and 1. Then they wanted you to recognize that the factors are actually 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. So if you have 2 to the power 4, 2 to the power of any number smaller than that, from 0 up to 4, they're all going to be a factor of it. And that's what you have to recognize in order to do the next few parts of the question. In part 2, you're asked to work out how many factors does 3 to the power 7 have. And you should recognize from what we did the last time, 2 to the power 4 had 5 factors. It was 2 to the power 0, 2 to the power 1, 2, 3, and 4. Well, obviously 3 to the power 7 then must have 8 factors, because it's 3 to the power 0, 3 to the power 1, 2, 3, 4, 5, 6, 7. So you don't have to actually list them out. Your answer is that 3 to the power 7 has 8 factors. Now for A part III, again, you should recognize that we're still on part A, which means it's obviously related to part 1, and part 2 was related to part 1 because it was II. But now you should recognize we're on the same idea. We're asked to work out how many factors does 2 to the power 10 by 3 to the power 12 have. First of all, you can't plug that number into your calculator anyway, it's far too big. So you have to just use what you've done already. Well, based on what we've done in the first two parts, 2 to the power 10 must have 11 factors. And 3 to the power 12 must have 13 factors. So it's 2 to the power 10, there's 11 factors there. 3 to the power 12, there's 13 factors there. If you simply multiply 11 by 13, you get the number of factors that this number has. It's 143. For part B of this question, we're told that Ava is analysing the pairs of numbers that multiply by each other to give you 12. And we're listed, the pairs are x by y. Basically, we're asked to list out the 6 pairs of numbers that multiply to give you 12. So it's 1 by 12, 2 by 6, 3 by 4, 4 by 3, 6 by 2, and 12 by 1. In part 2 of the question, we're given this diagram where along the x-axis it goes as far as 12, along the y-axis it also goes as far as 12. And we simply have to plot the different points. So basically you just plot the points 1, 12, 2, 6, 3, 4, and so on. And then for part 3 of the question, we're simply asked to draw the graph, which simply means we join up all the dots to form the curve. So that's all you have to do to get the marks for part B. In part C of this question, we're told that a tangent is drawn to the curve y equals 12 over x at the point P 12 over P. We're asked to get the equation of this tangent. Well, remember that a tangent is simply a line. And in order to get the equation of a line, we usually use, and in this case we will use, y minus y1 equals m times x minus x1. In order to use this formula, we need 2 pieces of information. We need the slope and we need a point. Well, we've been told that a point on the tangent is x1, y1. So that's what we're going to sub in for x1 and y1. The only thing that we need to find is the slope. So we need to find what the slope of this tangent is going to be, then we're going to sub into this formula and we'll manipulate our answer till it looks like the one given in the question. Now, the content that we've covered that relates to this is from differentiation 14. So if you weren't sure where to go here, you should go back and look at the tutorial in differentiation 14. The key thing here, in order to find the slope, you have to recognize that when a tangent touches off a curve, at the point where the tangent and the curve meet, then the slopes are the same. In other words, at the point of contact, the slope of the curve equals the slope of the tangent. I want to find the slope of the tangent here, but in order to find the slope of the tangent, what I'm actually going to do is find the slope of this curve. If I get the slope of this curve, then the slope of the curve and the slope of the tangent are the same at the point of contact. So in other words, just think back to your differentiation. The easiest way to get the slope of a curve is to differentiate. But before I differentiate, I'm going to simplify. I'm going to rewrite this as y equals 12, and this is an x to the power 1 on the bottom of the fraction. So if I bring it up, I can write it as x to the power minus 1. That's one of your rules of powers from page 21 in the maths tables. Now I'm going to differentiate. So now I want to get dy dx. You bring the power in front, so you'd get minus 12, and then the power decreases by 1, so it comes to the power of minus 2. And obviously I can simplify that down. Minus 12 times x to the power of minus 2 is the same as minus 12 times x to the power of plus 2. I'm using that rule of powers again to bring my x underneath. So the slope of the curve is minus 12 over x squared. I want to know what is the slope of the curve at this point. The point on the tangent is p 12 over p. Well, at this point, I know that the x value is p, which means the slope at the point of contact, I have to sub in, instead of x, I have to sub in the x value of my coordinate. The x value of my coordinate is p. So at the point of contact, the slope of the curve is minus 12 over p squared. And at the point of contact, the slope of the curve and the slope of the tangent are the same thing. So this, in fact, is the slope of the tangent. I now have the slope of the line, I have a point on the line. I'm just going to sub into the equation of a line formula and we'll get our answer very easily. So all I need to do is sub in to the equation of a line formula. My slope is minus 12 over p squared and the point is p 12 over p. So all I did was I subbed in x1, y1 and I subbed in m. And this is what your first line looks like. When you multiply out the right hand side, you get minus 12x over p squared and you get plus 12p over p squared. Obviously here, one of the p's on the bottom cancels with the p on the top. And what I also did on the next line was I isolated y. I took the minus 12 over p and I brought it to the right. It became plus 12 over p. So I end up with 12 over p minus 12x over p squared plus 12 over p. The first term and the last term here are like terms. 12 over p plus 12 over p is simply 24 over p. And that leaves me with the equation of my tangent in the correct format. And in the very last part of this question, we're given the line y equals minus 12 over p squared x plus 24 over p. And where the shaded region is the area between the line, the x-axis and the y-axis. And we're told that the area of this region is k, find k. In other words, find the area of this triangle. So the question is to find the area of a triangle. And the easiest way to get the area of this triangle is to use a half multiplied by the base multiplied by the perpendicular height. And it'll be easy enough for us to work out the base of this triangle. And it'll also be easy enough for us to work out the height of the triangle. In order to work out the base, we need to work out the x-intercept of the line. So we just need to identify, where does this line cross the x-axis, where does this line cross the y-axis. The thing that we know about the x-axis is that every coordinate every point has a y value of 0. So in this case, I'm subbing into this equation, except instead of a y, I'm subbing in a 0. And I'm just left with these two terms. What I did then was bring the x term to the left and it becomes 12 over p squared x. And then what I did on the next line was I multiplied both sides by p. Because if you multiply the left by p, you end up with 12x over p. If you multiply the right by p, you end up with 24. Then to get rid of the fraction on the left, I multiplied by p, and I get 12x equals 24p. Divide both sides by 12, and I worked out that when the y value is 0, the x value is 2p. In other words, the x-intercept for this line is 2p, 0. And then it's much simpler on the y-axis. You sub in x equals 0. Well, if we take this equation and we sub in x equals 0, then this term just gets cancelled out, and we're left with y equals 24 over p. So the y-intercept is 0, 24 over p. Let's go back to our diagram now and use this information to identify the area of the triangle. Okay, so now that we've identified the x-intercept is 2p0 and the y-intercept is 0, 24 over p, we can actually find the area of this triangle. If this is the point 2p0, then that means the distance from the origin to the point is 2p. And the distance from the origin to the y-intercept is 24 over p. In other words, the base is 2p and the perpendicular height is 24 over p. So now I can sub into my formula that the area of a triangle is a half by the base by the perpendicular height. In other words, it's a half multiplied by 2p multiplied by 24 over p. Now in this case, a half multiplied by 2 is simply 1. P on the bottom and a p on the top cancel out. So my answer works out as A is equal to 24 units squared. And in this case, we were told that the area is represented by the letter K. So that's your final answer for C part 2.